Okay, everybody, we're going to be going over Half Life today. So we're just going to get straight into it with the notes. And then we've got some practice examples. And then tomorrow you'll be doing your own practice with Half Life calculations. So, first, let's go back to what we talked about yesterday and Half Life. Let's see if we can fill in these notes right here. Half Life is the time necessary for blank of the atoms of an isotope to decay into something else. What do you think would go into that blank? Half, hence the name, right? So we're going to write half right here. So half life is an amount of time, it's a measurement of time, and it's the time needed for half of the atoms of an isotope to decay. Now, the second bullet point is pretty straightforward as well. Each time an isotope goes through a half life, so every time it goes through a half life, the number of atoms decreases by 2, right? Or half, whichever way you want to think of it. You're going to divide by 2, or if you want to think of it, it's decreasing by half every time. So if I start out with 100 grams, after it goes through a half life, I'm going to be left with 50 grams. After another half life, it's going to be 25. And then after another, it's going to be 12.5. This is what you guys talked about yesterday. Okay, so coming down here. So this is actually the half life formula that I have here on the left side here. Again, you could just plug things into the formula and solve. What happens is sometimes there's some issues depending on what you're having to solve for. Specifically, if you're having to solve for any of this stuff up here, and you end up having to deal with logarithms, and that gets a little wonky. So we're not going to worry about actually plugging and chugging in the formula, but I did want to show you the information from the formula. So if we look, NF equals NI. This is just the standard notation, the way we write this, times 0.5, that represents that it's going to be divided by 2 every time, raised to t over t sub 1 half. Now we're going to identify each of these things. What do you think F means in this case, this n sub F? What do you think the F means? We don't have time to wait, so it's going to be final. And you might be thinking, okay, well, what is the N? Well, this is where it's weird. So N actually means mass. You might think M means mass. But all this means right here, this NF means my final mass. So whatever mass it ends up as. So final mass. So you need to be writing this down. Again, people are just staring at the screen, but you need to be writing this down. So knowing that NF equals or means the final mass, what do you think NI might mean? Very good, the initial mass. So this is the mass that we started with. So Ni is the initial mass. Okay, T is pretty straightforward. What do you think T means? Time, but a specific amount of time. So T actually means the total time. So however long it has been. So if it's been 100 years, then that's what T is going to be. If it's been a million years, that would be our T. And the T sub 1 half, this one's kind of weird the way to think about it, but this is the time needed for 1 half life. Okay, so for example, in your lab, a half life was 10 seconds, right? And so that would be your T1 half. So T is your time, and half means, okay, that's the half life time. So the time needed for 1 half life, or how long a half life is. So again, these are all the things that you would plug into the formula, but like I said, we're going to try to work around the formula instead of having to worry about dealing with exponents. So coming over here, I just wanted to tie this back to the lab. So the half-life graph, what did your graph look like yesterday? Anybody remember? Yeah, it decreases. So we started out with a bunch, and it decreased pretty quickly, but then it started decreasing by a smaller and smaller amount. And that makes sense because if I started out with 100, in that case beans, but we'll say with 100 grams, when you cut that in half, well, half of 100 is 50. So that is a big drop. But half of 50 is 25. Well, that's not as big a drop. And half of 25 is 12.5. So that's not as big a drop. And so the drop keeps getting smaller and smaller and smaller. Interestingly enough, you'll never hit 0. right? Because what's 1 divided by 2? 0.5. Good job. So 0.5. Well, 0.5 divided by 2 is 0.25. And 0.25 divided by 2 is 0.125. So it just keeps getting smaller and smaller and smaller, and you'll never actually hit 0. Anybody remember what this is called in your math class, where it never actually touches the line? Y'all might not have learned it. I don't know. It might have just been the honors classes. It's called an asymptote. Y'all remember that term? Okay, yeah, so you remember that. So if you don't actually ever touch the line, that's called an asymptote. So just a little tie back. So that is what you should have seen in your lab. So you can check your graph on the lab. So again, we have the formula, but I gave you simple ways, basically little 2-step processes to be able to solve for anything you need. So let's look at the first one right here. If I need to know my final mass, so how much is left? Well, the trick to doing this very simply without having to use the formula is first determine how many half-lives it's gone through. So you've got to figure out the half-lives. And then depending on how many half-lives there are, that means you're going to divide by 2 each time. So if I had 10 half-lives, I'm going to divide by 2 10 times, divided by 2, divided by 2, divided by 2. So let's look at this first example that I gave you. Jimmy has 80 grams of Krypton 81. How much Krypton 81 remains after 4 half-lives? Well, let's come back to our steps. Step 1, determine how many half-lives it's gone through. Well, how many half-lives were there? This one just straight up tells you. Yeah, right? We've got 4 half-lives. So we've got 4 half-lives. So how many times am I going to need to divide by 2? I'm going to need to divide by 2 4 times. So I'm going to take my 80. So grab your calculator. Everybody grab your calculator. And let's do it together. So I'm starting with my 80 grams. So 80. I'm going to divide by 2. So there's 1 half-life. I'm going to divide by 2 again. Fortunately, I can just hit enter and it's going to do it again. So there's my second half-life, my third half-life, and my fourth half-life. So I divided by 2 4 times. And what was my final mass? How much did I end up with? 5 grams. So 5 grams equals my final mass. Okay, I want you to try. We're not going to do example 2 yet. I want you to try another one like 1. So let's say instead of 80 grams, you started with 240 grams. And let's say instead of 6 half-lives, you go through, 4 half-lives, we're going to go through 6 half-lives. So let's see if you can figure out what would the final mass in this scenario be. So if I started with 240 grams of Krypton 81 and we go through 6 half-lives, how many would that be? So I doubt you can do it in your head, so you'll need to use your calculator to get this. So again, determine how many half-lives. I gave it to you straight up, and then divide by 2 for every one of those. 3.75. Let's check it. So how many times am I going to divide by 2? 6. So here we go. There's 1, 2, 3, 4, 5, 6. You are correct. We would end up with 3.75 grams of that Krypton 81. Okay, so we're good with that. Just straightforward dividing by 2 each time. Let's move to example 2, because in this one, I didn't just give it to you straight up. I wanted you to be able to figure it out. So example 2, Jesus has 360 grams of radon 216, which has a half-life of 30 minutes. What mass of radon 216 remains after 180 minutes? So did I give you how many half-lives there were? No. So if we come back to step number 1, it says determine how many half-lives. Well, how might we figure out, based on the information we have here, how might we be able to figure out how many half-lives there were? Okay, you're on the right track. So there's kind of an easier way to do what you said. So we're going to come back to the formula. If we take our total time, which is always going to be the bigger number, and divide it by however long a half-life is, that's going to tell me how many half-lives there are. So let's look at this. So how many, or what is my total time here? 180 minutes. So we're going to say 180 minutes. And how long does it take for one half-life? 30 minutes. So how many half-lives are we going to end up with here? 6 half-lives. Very good. So now that we know our 6 half-lives, it's just like what we did in example 1. So you go ahead and solve and see if you can figure out what is our mass going to be for example 2. So all we did is we took the total time, we divided it by how long a half-life is, and that tells us how many half-lives there are. So 6 times. So how many times am I going to have to divide by 2? 6. So here's my first. So there's 1, 2, 3, 4, 5, and 6. So my final mass that I would end up with in this scenario is 5.6. I'm going to round 5.63 grams. So 5.63 grams specifically of that radon 216. Okay, so if the half-life is not given to you specifically, what you'll need to do is you'll take the total time, divide it by however long a half-life lasts, and then that'll give you how many half-lives there are. Okay, let's come down to the next scenario. In this case, it's kind of the opposite. We're still going to do everything the same, except instead of dividing, we're going to multiply because we want to know how much did we start with. So the initial mass. So same concept. We got to figure out how many half-lives there are. And once we know how many half-lives there are, in this case, we're working backwards. So instead of dividing by 2, we're going to multiply by 2. So let's come down to example 1. Carlos observes a sample of carbon-14 that has a mass of 2.5 grams. Assuming the isotope has undergone 8 half-lives, calculate its initial mass. Well, step 1, determine the half-lives. Well, how many half-lives are there? 8. So we got 8 times that we're going to have to multiply by 2. So we've got 8 half-lives. That means it was originally cut in half 8 times. But now we're going to work backwards. So now we're going to, for every half-life, multiply by 2. So we're going to start with our mass, 2.5 grams. And I'm going to multiply it by 2 8 times. So here's 1, 2, 3, 4, 5, 6, 7, and 8. So 640 grams is what we would have had initially. 640 grams. 640 grams. And again, specifically of carbon 14. Okay, same thing. I'm going to change the numbers here. Let's see if we can figure it out. Let's say instead of 2.5 grams, we start with 8 grams. And instead of 8 half-lives, we're going to go through 10. So 10 half-lives. Let's see if we can figure out what was our initial. We're trying to figure out our initial mass here. So how many times are we going to have to multiply by 2? 10 times, because we have 10 half-lives. So again, I'll pull up my calculator. So 8 times 2. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you did it correctly, you'd get 8,192 grams. Is that what you got? Okay, good. So 8,192 grams. Okay. Any questions on that before we move on to example 2? Pretty straightforward, right? You're just multiplying, you're just dividing. There's not really anything crazy here. So example 2 is very similar to example 2 from the previous one. So let's look. So a 10-gram sample of an isotope with half-life of 2 years, so I'm giving you a half-life of 2 years, has been sitting for 20 years. What was the mass of the sample 20 years ago? Well, notice I didn't give you how many half-lives there are. So that means the first thing we need to do is figure out how many half-lives there are. So how will I go about doing that? Very good. Easy way to say it. She said it perfectly. Divide the big number by the small number. So I've got my 20 years is my total time. So 20 years divided by my half-life time, which is 2 years. What's 20 divided by 2? 10. So now I know that I've got 10 half-lives that this went through. And if it went through 10 half-lives, that means I'm going to have to double it 10 times. So I started with 10 grams. So I'll pull up my 10 grams, and I'm going to multiply it by 2 10 times. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10,240 grams. 10,240 grams of that isotope. Amina, any questions? Is it good? Okay, good deal. Okay, so for the next two types, these are where it's with the formula, it's where things get difficult with the formula, but we're going to try to, again, not have to deal with exponents. So let's come down and look and see what I said to do. So in this case, how many half-lives were there? Now, we've already figured out how to figure out half-lives if we're given time, but in these, I'm not giving you the time. So how is it that we would figure out the half-lives? So let's look. Divide the initial mass by 2 until you reach the final mass. However many times you had to do that, that is how many half-lives there were. So you don't even actually have to type any real stuff into your calculator. You're just going to divide by 2 until you get your answer. So let's look. A 1,000 gram sample of an isotope decays to a mass of 781 grams. So which one is my initial mass? The 1,000. And how do we know that this is the initial? Okay, there's a couple ways. One, we see that it decays. So that means it started out with this and decayed. Also, it's the bigger number, right? So there's a couple ways to figure this out. So this is my initial. So that means this one is my final. And so divide the initial mass by 2 until you reach the final mass. So let's look and see what we got. So we start with 1,000. We're going to divide by 2. We're trying to reach 7.81. So let's see how many times it takes to do that. So there was 1, 2, 3. Sorry, I hit that kind of fast. 4, 5, 6, 7. So it took 7 times for that to divide by 2 to get me that. So how many half-lives did this go through? 7. Right? So there's my answer. I don't have to take it any further. I just divided this by 2 until I got to this number, and it took me 7 times. So this was 7 half-lives. Okay, example number 2. A sample of nitrogen-12 has a mass of 2 grams. Assuming the initial mass was 2,048 grams, how many half-lives did it go through? So this is exactly like example 1, so I want you to see if you can answer it, and then we'll go through. So I'll give you about a minute to see if you can figure out how many half-lives did it go through. Okay, what are we going to start with? And which is? Very good. The big number, 2,048. So I'm going to start with 2,048. I'm going to divide by 2 until I reach my final mass, which was 2 grams. So divided by 2. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many half-lives? 10 half-lives. That's it. So it took me 10 times. So that tells me this would be 10 half-lives. Okay, and for the last one, this is the hardest one. Okay, but it's really only one step further than what we just did. So in this case, if I wanted to know how long did it take for all of this to happen. So let's look at it. First, you got to figure out how many half-lives there were, just like we did in this previous section. So you just divide by 2 until you figure out the half-lives. Then, once you know that, I need to fix that. That should be multiply. The half-lives by the time it takes for a single half-life. So once you know, so for example, this one's 10 half-lives. Well, if we knew how long a half-life takes, then we could just take it and multiply it by 10. Or this one, multiply it by 7. And actually, for these examples, I pulled the exact same questions. I just added this on to the end. So let's look at number 1. A 1,000 gram sample of an isotope decays to a mass of 7.81 grams. The isotope has a half-life of 5 years. How long did it take for this sample to decay? So step 1, determine the number of half-lives. So what would I do to get the number of half-lives? Yeah, just like we did up here. And I'm not going to do it again because it's right here, right? So I take my initial, I divide it by 2 until I get to my final, and that determines how many half-lives that I've got. So I did it up there, so it was 7 half-lives. And now that I know my half-lives, I need to multiply it by the time it takes for a half-life. Well, how long is a half-life based on this question? The isotope has a half-life of 5 years. 5 years. So I'm going to multiply that by 5 years. So we've got 7 half-lives. Every half-life takes 5 years. Well, what's 7 times 5? 35. Good. So 35 years is how long this took to do that. So that means that that sample has been sitting there for 35 years. Every 5 years, it was cutting in half. Every 5 years, it was cutting in half. Okay, let's come down to example number 2. Last one here. A sample of nitrogen 12 has a mass of 2 grams and a half-life of 4 days. So this is that initial or additional information I gave you. Assuming the initial mass was 2,048 grams, how many half-lives did it go through? How long did it take? Well, again, we've already figured out how to get the half-lives. We take our initial mass, which in this case was 2,048 grams. We divide it by 2 until we get to our final mass, which was 2 grams. So again, we'll just do that really quickly. 2,048 divided by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it took 10 half-lives. So from that, we know that we had 10 half-lives. And then lastly, we need to multiply that by however long a half-life takes. And how long does a half-life take? 4 days. So 10 times 4? 40 days. So that tells me that it took 40 days for this sample to decay. If we had these particular numbers, it would take 40 days for this sample to decay. Okay, so what we're going to do now is I'm going to stop the video and we're going to just do some practice ones up here on the board. Make sure everybody feels comfortable with them.